Hello friends, myself Anjali Bhosle, Assistant Professor, Department of Statistics at Rajarshi Chhatrapati Shahu College, Kolhapur. In previous lecture, we have to discuss about correlation, and today's lecture we will discuss about assumption of correlation. First one, no distinction between exploratory X and response Y variable. The null hypothesis tests that R is significantly different from 0. Requires both variables to be quantitative or continuous variables. Both variables must be normally distributed. If one or both are not, either transform the variables to near normality or use an alternative non-parametric test of Spearman. And last, use Spearman correlation coefficient when the shape of the distribution is not assumed or variable is distributed free. Assumption of Pearson correlation coefficient. There is a linear relationship between two variables, that is, when the two variables are plotted on a scatter diagram, a straight line will be formed by points. Cause and effect relation exists between difference forces operating on the item of the two variable series. Our next point is Karl Pearson coefficient of correlation. Pearson's small r is the most common correlation coefficient. Karl Pearson coefficient of correlation denoted by small r. The coefficient of correlation small r measure the degree of linear relationship between two variables, say x and y. The coefficient of correlation small r is equal to n into summation xiyi minus summation xi into summation yi divided by in square root n into summation xi square minus summation xi whole bracket square into square root n into summation yi square minus summation yi in bracket square, where r is equal to coefficient of correlation. R is belong to -1 to +1 and n is the number of data points. Thank you.